Okay, this is exercise 8.10, compound interest. So exercise 8.10, compound interest, this is nothing really new. You did this work in year 10. So the compound interest formula, A equals P, 1 plus R to the N, where P is the principal, R is the interest rate as a decimal per period. Per period. N is the number of periods. A is the amount, the final amount.
We don't get that in our formula sheet.
So, we've seen the formula like this, and it's like this in your textbook, but on the formula sheet it's written like this. Little r on the formula sheet. So, capital R would be the interest rate as a decimal, where it's 6 over 100, for example. If the interest rate was 6%, it's 6 over 100, but here they're showing that you need to put it over 100.
Oh,
Okay, yeah. So in the past, in year 9 and 10, whenever you did compound interest, the formula was like this, and you had to convert that to a decimal. So capital R is the interest rate as a decimal, little r is just the interest rate. But when you divide it by 100, it ends up being a decimal. Okay, so this is the one on the formula sheet. Little r is just the interest rate, like 6 or 5 or whatever it might be. Now, just going to draw that little table with what you do with R and N for different compounding periods. So, with different compounding periods, you can either get annually, compounding annually, you can get compounding 6 monthly, you can get compounding quarterly, or you could get compounding monthly. Now, depending on these, which one you get in your question, you need to change your interest rate. So, I'll just put R for your interest rate and N for periods, number of periods. So, if, for example, your interest rate is compounding annually, you just keep it the same, R and N. If your compounding period is 6 monthly, whatever your interest rate is, you divide it by 2, and whatever your N is, you times it by 2. For example, if your interest rate was 6% per annum, you would do 6% divided by 2, 3% for 6 months. And your periods, let's say it was 5 years, instead of being 5 years, it would be 5 times 2, it would be 10 periods of 6 months. If your interest rate is compounding quarterly, or if your interest, is compounding quarterly, you need to take the interest rate that they give you and divide it by 4, and whatever your N is, you'll times it by 4. For example, if your interest rate is 8% per annum, it would be 8 divided by 4, 2% per quarter. And if you had, say, 3 years, you'd do 3 times 4, 12 quarters. And if your interest rate is compounding monthly, you need to take your interest rate and divide it by 12 to get your monthly interest rate. But then your periods would have to be expressed as months as well. So you would take your number of periods and multiply that by 12. So we'll just do 2 examples. Questions here. Question 20 from exercise 8.9. A bank offers investment account A. So we've got account A has 8% per annum interest. 8% per annum with interest paid twice a year. So the interest rate is 8% per annum, but it's compounding twice a year. So I don't want it per annum. What do I want? What am I going to do with that rate? I divide it by 2, which is 4% per period, because it's per 6 months. Okay? Now, that's account A. Account B, interest 6% per annum. R is 6% per annum, but it's compounding at monthly intervals. So it's going to be 6 divided by 12% per month, which is what percent? 0.5% per month. Now, I've only done my R there. I still have to do my N's, okay? And then it says if Georgie invests $5,000 over 6 years. So my N is 6 years, but because I divided my rate by 2, so here I'm going to go rate divided by 2, N times 2. Okay, so that I remember to do it. I'll just make this a bit bigger. Actually, I'm going to make... Have you seen the question now?
Yeah.
I know, it's... Yeah, they're two different accounts. So the first one, account A, we know it's 6 monthly, so we've got to do the rate divided by 2 and N times 2. So N was 6 years, but I have to go 6 times 2 is 12 periods of 6 months. Does that make sense? So what I like to do actually, I like to write my R first and then my N, and then I divide my R by 2, and then I times my N by 2. Okay? So with the next one, account B, it's compounding monthly, so I've got to do my rate divided by 12 and my N times 12. So I've done my rate divided by 12. N was 6 years, but I don't use 6 years. I have to change it to what? 6 times 12, which is 72 months. So girls, the interest rate needs to be per month and the number of periods needs to be in months. With the first one, the interest rate is per 6 months and the number of periods is 6 monthly periods. Okay, so just be careful, make sure we're using the correct amounts. So for the first one, we're using 4% and 12 periods. For the second one, we're using 0.5% and 72 periods. And it says Georgie invests $5,000 over 6 years. Which account pays the most interest? Okay, I'm going to get rid of that question now. And how much more interest does it pay? So with the formula A equals P1 plus R to the N, A is the final amount that you end up with. So we're going to use 1 plus R over 100 to the N, because that's what's on the formula sheet. Principal is $5,000, 1 plus 4 over 100 to the power of 12 for the first one. So girls, you actually don't need to go use your bracket for your calculator, because what I like to do, I just go 5,000 times. 4 over 100 is 0.04. It's times 1.04 to the 12, and then you don't need to go and put fractions in.
Yeah.
All right? And then you can just do that one. And the other one is A equals, again, the same formula, P1 plus R over 100 to the N. 5,000, 1 plus 0.5 over 100 to the 72. Please don't forget to divide the 0.5 by 100. A lot of people do forget to do it because they feel that the 0.5 is small enough as it is, but the 0.5 still needs to be divided by 100. So it's 5,000 times 1 point, this would be 0.005 to the 72. So now you can compare the final amounts for each of those investments.
5.161.
8,005 point,
16109.
that'll do 16. And just 2 decimal places for money. And the second one?
That's 7,160.22.
No, guys. So just looking at this, sorry, they are different interest rates. I thought they were same interest rate, but they weren't. But if they were the same interest rate, the one compounding more often gives you more interest, because the interest with the second scenario, scenario B, your interest is added on at the end of each month, and then you earn interest on your interest. Okay, so with the first one, interest is added on at the end of every 6 months, but they're different interest rates. Okay, so therefore account A earns more, and you can subtract the amount to find the difference. Okay, so therefore account A earns more interest. And to work out the amount of interest, what will you do?
Isn't that the interest?
No, this is not the interest. This is the final amount. Here is not the interest. It's different to the simple interest formula. A is the final amount. And so therefore the interest for the first one is $8,005.16 minus the $5,000 principal, which is $3,005.16. And the interest for account B is going to be $2,160.22 cents. Okay, so account A earns more interest. it says by how much, so by, so we just subtract, and you get, I don't know what you get, it's 800 and something dollars, 800 and whatever you get. So the difference between the interests is what do we get? 844.94. Okay. Now, in some other questions, girls, you'll have to work out n number of periods and things like that. I might just do one more and then we'll move on. Questions from this exercise, just a couple of the ones where you work in reverse. So, question 15, how many years ago was an investment made if $5,000 was invested at 6% per annum paid monthly and is now worth 6,352.45? So, the principal is 5,000. It's compounding monthly. The final amount A is, now that's not the interest, that's the final amount, but that's what you put into your formula because it's A equals P, 1 plus R to the N. The interest rate is 6% per annum, but it's compounding quarterly, not compounding monthly, so it's 6 over 12% per month, which is 0.5% per month. Now, when you use the compound interest formula here, A equals P, 1 plus R over 100 to the N, your N is going to come out in what units? Months. Okay? So when they want to know how many years ago, you're going to have to convert it back to years. Okay? So A is 6,352.45. The principal is 5,000. And it's 1 plus 0.5 over 100 to the power of n. So you can put, what's 6,352.45 divided by 5,000? So 6,352.45 divided by
1.2704
equals 1. I'm going to add these together now, 1.005 to the n. So that is the same as 1.27049. Exactly. So no rounding off.
I can double check.
Equals 1.005 to the n.
Obviously, it's not 635, it's
6,352.45. 6,352.45. Yeah, no, that's okay. I just wrote it wrong.
Yeah, 1.27.
Etc. Now, just make sure that's not rounded off. Now, what are we going to do? Take log of both sides and bring the n to the front. So therefore, ln 1.27049 equals ln 1.005 to the power of n. And we just keep going. So I'm going to I'll just keep going down here. So therefore, n is ln, so we've got to bring so we've got ln 1.27049, I've written it wrong, equals n ln 1.005. So therefore, n is ln 1.27049 divided by ln 1.005, which is this 48.000. So it's 48 months. Remember, this is in months. Well, if it was, I think they've made it work so that it will work exactly for you in this. Because look at there, it's now worth 6,352.45. But if it'd be different if it would say how many months do I need to invest to get to 7,000 or something like that. You'd have to round up, because if you rounded down, you wouldn't get to that amount. Okay? So it's 48 months, therefore how many years? Therefore the number of years is 48 divided by 12, which is 4 years. So therefore the investment was made 4 years ago. So just understand with the compound interest formula, if you're putting an R in that's in months, the N will spit out in months. Okay? All right, I think you should be okay to work the rest out. All right? I'll just set some questions for question 14, 16, 17, 18 and 19. That's enough for that exercise. We're now going to go on to the next exercise.